Hello students, today we are going to discuss about an interesting topic. Have you ever imagined that how hot air balloon rises up? Because it is less dense. Okay, so we will discuss about pressure, air pressure. Okay, that is atmospheric pressure and winds. Atmospheric pressure. Lesson number 6. And winds. In the previous lesson, we have studied about the elements of weather and climate, where we have seen that there were some interesting topics like temperature, atmospheric pressure, humidity and rainfall. So today we are going to discuss about one of those elements, that is the atmospheric pressure and winds. And you must have to know that it is the second major element influencing weather and climate. This is an element of weather and climate. You may know that, as I have already told you, air occupies space and has weight. It is proved with it can be proved with the help of a balloon. If you blow it, you will easily understand, because it will create weight. It will have weight, and plus what it can show that air occupies space. The balloon will become larger. So anything which occupies space and has weight exerts pressure too. So atmospheric pressure is simply the weight of the atmosphere per unit area. It is the force exerted by air on the surface of the earth. On the surface of the earth, it is the force exerted by air. It is measured with the help of barometer. An atmospheric pressure is measured in millibars. Okay, millibar, which is written in MB, you can see that. Okay, that we will discuss here. So what is there in this diagram? In this diagram, you could see, I would like to make you some understanding regarding some altitude. You could see these are varied altitudes. These are different altitudes. Okay, this is 0 meter. This is sea level. Above the sea level, you could see plains and hills. Small hills were there. That is 1000 meter, the altitude above sea level, and you could see mountains. The altitude here is 1800 meter. Okay, those who cannot see, thus you can see that this is 1800 meter and this is above sea level written there. Okay, so sea level, the sea is there or ocean is there, that is the sea level, that it is called 0 meter. Here you can see 28 degrees Celsius of temperature is there, and the atmospheric pressure is very high. Here you can see 1008 millibars. Okay, that is millibars. Then you could see above sea level, that is plains and hills, 1000 meter, and the temperature also becomes little bit lower here, that is 24 degrees Celsius, that is, and the atmospheric pressure comes 915 MB. Above it, if you see, the mountains were there. It is 1800 meter above sea level, and the temperature slightly decreases here, that is 20 degrees Celsius and 840 MB, and even the atmospheric pressure also decreases. Why? Because the air here is less dense. Okay, the more denser air you will get here in the nearby the sea level. Okay, so that is to make you understand what will be the air pressure and where will be the air pressure more. Where will be the air pressure more? Wherever the sea level is there, just nearby the seas and oceans. And wherever the atmospheric pressure will be less, that is in the mountains. So sometimes we could see that the mountain trekkers used to get some kind of problems, a disease. Okay, what happens? They used to, the blood used to come out from the nose due to trekking in the mountains. Okay, that is a common problem found in the mountain trekkers. So I hope you understand the three different varies regarding atmospheric pressure. Atmospheric pressure can't be same in these three different areas. So three different areas, three different types of atmospheric pressure you could see. The highest is in here in the sea level and the lowest is in the mountains. Now let's talk about the factors influencing atmospheric pressure. So this is, I make you understand regarding that. Altitude, okay, air pressure is highest at the mountains, the mean sea level. Air pressure is highest at mean sea level and decreases with increasing height because of thinner atmosphere. Okay, not only that, the temperature will also decrease. Then we could see air temperature. Cold air exerts greater pressure, I mean to say higher pressure, as it is heavier than hot air. I told you during the winter season what happened. If you just open your doors and windows at night or in the evening, you can feel cold air is coming inside and the hot air is going outside. That is a good example for that. The cold air exerts more pressure, greater pressure, and hot air rises up. Then the third factor is that is the moisture content. So moist air is lighter than dry air. Okay, moist air is lighter than dry air because the molecular weight of the water is less than the weight of oxygen and nitrogen. This is a scientific fact. Okay, so you could understand through the help of your science book. Now let's discuss about the pressure belts of the world. So there were 4 permanent pressure belts. Okay, there were 4 permanent pressure belts, whereas another 3 non-permanent belts were also there. But in the book there are only 4 pressure belts, 4 permanent pressure belts. That is, the number 1 is the equatorial low pressure belt, or the ITCZ, 0 to 5 degree north and south. Okay, this is the belt, 0 degree to 5 degree north and south. 0 degree is the equator. Just above it 5 degree and just below it 5 degree north and south. 0 degree to 5 degree north and 0 degree to 5 degree south belongs to the equatorial low pressure belt. As the name suggests, equatorial low pressure means hot air or warmer air. Okay, warm air. Then the subtropical high pressure belt. High pressure means cold air. Okay, so 30 degree north to 35 degree north and 30 degree south to 35 degree south. Then comes the subpolar low pressure belt, that is 60 degree north to 65 degree north and 60 degree south to 65 degree south. Then the polar high pressure belt, 85 degree north to 90 degree north and 85 degree south to 90 degree south. So those are their areas. Now let's talk about in brief. Equatorial low pressure belt, as the name suggests, it is a low pressure belt or low pressure area. The rays of the sun fall vertically on the earth's surface here directly. Okay, so the level of insolation, that is long hours of exposure, okay, is high here. This zone is also known as doldrums. It is also referred to as the ITCZ. ITCZ means intertropical convergence zone. Intertropical convergence zone here means there were 3 tropics. One is the torrid zone, next is the temperate, and then the frigid zone. So from there what happens, the air used to come and mixes there in the ITCZ. ITCZ means 0 to 5 degree north and 0 to 5 degree south. Here different air trade winds comes and mixes. Now subtropical high pressure belt, you could see here the name suggests high pressure belt. This area is an area of high pressure. It is also called as horse latitude, also known as horse latitude. Here the air loses heat through radiation coming from equator. That means the air coming from equator loses heat through radiation. Next is the subpolar low pressure belt. You can see the low pressure, subpolar low pressure. So low pressure means warm air. Okay, so here this is a zone where 2 wind system converge. Converge means mixes. Okay, the prevailing westerlies and the polar easterlies. The name is the prevailing westerlies and the polar easterlies. Okay, these 2 wind system mixes up. These 2 wind system mixes here in the subpolar low pressure belt. It is a low pressure area, as I told, and this is a zone of storms caused by the powerful uplift of air. Here also in the ITCZ some kind of storms used to come up, cyclones used to come. Then comes polar high pressure belt. As the name suggests, polar high pressure, it is a cold area, and it is a high pressure belt area. So it is found over the north and south poles. In the poles, okay, you will get it is a high pressure belt area, and these areas are also known as polar highs. Polar highs, AS, okay, polar highs. These regions are characterized by permanent ice caps. Here you will get permanent ice caps. Now next is the wind systems. Winds, as you all know, moving air is called wind. Wind vane is used to study wind direction. So wind speed is measured with the anemometer. Now you could see winds, okay, those winds who comes from the west, they were known as west winds. Those winds who comes from the north, okay, they were known as north winds. Those winds who goes through south, they were known as south winds. In the same way, from wherever it blows, the name comes. So suppose winds are blowing from the eastern side, then they will be known as eastern winds, okay. If it is moving from southwest, west and south, then it will be known as southwest winds, okay. So now two important things, Coriolis force and Farrell's law. So what is Coriolis force? Winds are affected by the rotation of the earth. As earth rotates, the winds also has some difficulty in their moving. It is affected. So instead of blowing straight from an area of high pressure of an area of low pressure, the winds are deflected, okay. They were going from here, they must have to go straight, but they were not going straight because of this Coriolis force. The winds are deflected or turned aside by the force of rotation, which is called the Coriolis force. Winds, when deflected because of the rotation of the earth, they were known as the Coriolis force. The deflection is explained by Farrell's law. Farrell's law explains the Coriolis force properly. You could see that. So there are three different types of winds. They can be basically divided into three, that is permanent or planetary winds, periodic winds and local winds. Let's discuss through permanent winds. Permanent winds were those winds, they are called permanent winds because they blow throughout the year. It doesn't mean that they were moving today from here, tomorrow they will move from here. It is not like that, okay. From wherever they were moving, in the same way constantly they used to move, so that they were known as prevailing winds or planetary winds or permanent winds. They are of three types. Permanent winds were also of three types, that is trade winds, westerlies and polar winds. So what is trade winds? Trade winds blow from the subtropical high pressure belt to the equatorial low pressure belt. So where is subtropical high pressure belt and where is the equatorial low pressure belt? I told you now, where is it? 0 to 5 degree north and south, that is the equatorial low pressure belt. And where is the subtropical high pressure belt? You could see this is subtropical high pressure belt, okay. So what it is told here, the trade winds blow from the subtropical high pressure belt towards the equatorial low pressure belts and mixes there. So now in the northern hemisphere, these trade winds were known as northeast winds in the northern hemisphere, and in the southern hemisphere it is known as southeast trade wind. In the northern side from the equator, known as northeast trade winds, and the southern side is known as southeast trade winds. They always blow in the same direction constantly. Then comes the westerlies. Westerlies blow from the subtropical high pressure belt to the subpolar low pressure belt, okay, from here to here, second number to the third number, okay. And there is an important thing here. They blow constantly from the west. The important thing is here, within our earth from 40° to 70° latitude, there is no huge land masses or higher mountains to stop these winds as they blow from, you could see, 60° north to 65, 60 to 65, and 30° north to 35. Okay, so within this, when they blow, in between of these degrees there is no huge land masses to stop the winds, so the winds become more faster and faster. So different names were given to it regarding these westerlies. So westerlies were known as roaring 40s in the 40° belt, in the both side, okay, equator above it, and northern and the southern side, and furious 50s in the 50° belt, and the screeching 60s in the 60° belt. Let's just discuss about the polar winds. Polar winds that blow from polar high pressure belt. In the north they are called polar northeasterlies, and in the south they are called polar southeasterlies. These winds are very cold. The next comes periodic winds. Periodic winds, you know, those who come after a season or after a year, okay, within a period without fail. Okay, so they do not blow permanently like the permanent winds, they blow on time. Like a good example is the Bordosila is also a good example. Okay, Bordosila comes to Assam during the during a particular season. Okay, so the monsoon winds and the land and sea breezes were great example for the periodic winds. The monsoon comes during its own time, during July. The monsoons, you could see, the monsoons are winds that blow in the tropics. They are rain bearing winds that are of vital importance to the areas over which they blow. So in the summer months, what happened? How do the rainfall happen? In the summer months, the interior part of the Asian landmass get heated intensely. Summer, this is the summer season going on. So you could see now the temperature of these areas, the Tibetan Plateau and the Indian Peninsula, becomes warmer. Okay, warmer. If it becomes warmer, means this is a low pressure area. Okay, this is a low pressure area. This is a low pressure area. So as it is a low pressure area and it is a warm area, the Indian Ocean here is cooler and having high pressure. Okay, it is cooler and having high pressure. So you just have to know that the cooler air, the high pressure winds will push back the low pressure area winds and they will rise up. Okay, so it is told here in the summer months, the interior part of the Asian landmass get heated intensely, leading to the development of a strong pocket of low pressure area here. The Indian Ocean, which surrounds the Indian Peninsula, is cooler during this time, because of which condition of high pressure prevail here. And the southeast trade winds, you can see this is southeast. So southeast trade winds here in the equator, it crosses the equator. When it crosses the equator, the southeast trade winds, when it crosses the equator, due to the Coriolis force, it turns towards right. As you know, you may think that it turns towards right means it must go towards your right. So okay, if it goes right, where it will go? It is a globe. Yes, globe, earth. Okay, earth is what? What is its shape? It is spherical or round, you could say. So if it is round, so it comes from here again. This is the southwest monsoon. The name comes here, southwest. Why? Because the wind starts moving from southeast, but due to Coriolis force, it deflects toward different direction. That is on your right. If it deflects, as it is a globe, it's a spherical and round. So what happens? It is coming from the southwest. Actually, it must enter India from southeastern side, from here. From here it must enter, but it doesn't enter from here. It enters from the southwest because of the Coriolis force. Okay, it deflects, and Like this, the rainfall starts from Kerala and to whole over India. Land and sea breeze. Land and sea breeze, I hope you all understand what is land and sea breeze. So land breeze, wind blows from sea to land during daytime, and the night time what happens, the land breeze used to enter. So that is you could easily understand through sea and ocean, where you could see that from the sea what happens, high pressure prevails over the sea and low pressure. During daytime, high pressure prevails over the sea. During daytime, land gets heated faster and ocean or sea doesn't get heated. So due to which what happens, the air transfers from high pressure to low pressure, that is from the ocean to the land. And at night what happens, the land gets cooler faster and the wind from the land breeze used to come and joins the sea. Okay, then local winds, you could see local winds are unique. Local winds, Bordosila is a good example of local winds. Okay, certain well defined area is there, they blow over a small area for a particular period only. So for example, the Lu is there. The Lu is a hot, dry and dusty wind that blows in the northern plains of India during the summer months. So now Lu will start in the Ganga plains. Then comes the Harmattan. The Harmattan or the Doctor is a dry, dusty wind that blows over northwestern Africa. It blows south from the Sahara Desert towards the Gulf of Guinea between the end of November. You could see that one. The dust carried by this Harmattan cause severe visibility problem. You cannot see. Okay, the visibility becomes zero. Then the Fan. Fan is a general term for any warm, strong and dry local wind that blows down the slope of mountains. It was originally a term used for local winds that blew down the European Alps. Okay, Fan type of winds can often raise the temperature in places over which they blow by up to 30 degrees Celsius within few hours. Okay, the Chinook. Chinook is a Fan type local wind which blows in the eastern flank of the Rockies, a mountain chain in North America. It is a hot and dry wind and its onset results in the melting of snow in this area. Very dangerous. These are all hot air winds. So I hope you understand. With this I conclude my lesson. Thank you. Comment if there is any difficulty and please try to do this question answer by yourself. If there is any difficulty, please comment or please message me through WhatsApp. Thank you.